In today's lecture, we're going to talk about the chi-squared goodness of fit test. A tax preparation company wants to check to see the proportion of people who use different methods to prepare their taxes. To determine these proportions, the company can perform a multinomial experiment. A multinomial experiment is a probability experiment consisting of a fixed number of independent trials in which there are more than two possible outcomes for each trial. The probability of each outcome is fixed, and each outcome is classified into different categories. The company wants to test a retail trade association's claim concerning the expected distribution of proportions of people who use different methods to prepare their tax. So they're going to run some tests. To do that, the company could compare the distribution of proportions obtained in multinomial experiment with the association's expected distribution. To compare the distributions, the company can perform a chi-squared goodness of fit test. Definition. A chi-squared goodness of fit test is used to test whether a frequency distribution fits an expected distribution or not. We have some processes to follow. To begin a goodness of fit test, you must first state a null and alternative hypothesis. Generally, the null hypothesis states that the frequency distribution fits an expected distribution, and the alternative hypothesis states that the frequency distribution doesn't fit the expected distribution. For instance, the association claims that the expected distribution of people who used different methods to prepare their taxes is shown below. Accountant, 24%. So 24% of people use accountant to do tax preparation. By hand, 20%. Computer software, 35%. Friend family, 6%. Tax preparation services, 15%. To test the association claim, the company can perform a chi-squared goodness of fit test using these null and alternative hypotheses. Null hypothesis says the expected distribution of tax preparation methods is 24% by accountant, is 20% by hand, is 35% by computer software, is 60% by friend or family, and it is 15% by tax preparation service. This is the claim. Its opposite, its alternative is the distribution of tax preparation methods is not, differs from the expected distribution. Okay, our goal is eventually to test this claim. Let us begin. To calculate the test statistic for chi-squared goodness of fit test, you can use observed frequencies and also expected frequencies. So we need to form two different things, observed frequencies and expected frequencies. To calculate the expected frequencies, you must assume the null hypothesis is true. Definition. The observed frequency, which is denoted by O, of category is the frequency for the category observed in the sample data. The expected frequency, denoted by capital E, of a category is the calculated frequency for that category. Expected frequencies are found by using the expected or hypothesized distribution and the sample size. The expected frequency for the ith category is E sub I equals to N times P sub I. N is the number of trials or the sample size. P P sub I is the assumed probability of the ith category. Perfect. In this example, a tax preparation company randomly selects 300 adults and asks them how they prepare their taxes. The results are shown on the right-hand side. Find the observed frequency and the expected frequency using the distribution on the preceding page for each tax preparation method. So take a look. Accountant, 61. So out of 300 people, 61 are using accountant. Out of 300 people, 42 of them are using hand. Out of 300 people, 112 of them are using computer software. Out of 300 people, 29 are getting help from friend and family. Out of 300, they use tax preparation services, which is just 56 of them. The observed frequency for each tax preparation method is the number of adults in the survey naming a particular tax preparation method. The expected frequency for each tax preparation method is the product, is the multiplication of the number of adults in the survey and the probability that an adult will name a particular tax preparation method. The observed frequencies and expected frequencies are shown in the table. So your first column is tax preparation. The second column is the percent of people. The third column is observed frequency. And the last column is expected frequency. Accountant, remember from previous page, it counts 24%. From this survey, you have 61, which is observed frequency. So the expected frequency is 300 times 24%. Again, these percentages are from previous page. Previous page. We need to have these information. These information form our null and alternative hypothesis. Remember that. Those are the hypothesized information. But the observed frequency is coming from our survey, and the expected frequency, we have to do the algebra ourselves. Here we go. We have 300 people in our survey. The percentage coming from previous page, 24%. If you do the multiplication, you get 72 as expected frequency. Now for by hand, from previous page, the percentage of people was hypothesized as 20%. The observed frequency says, hey, I have 42 out of 300 people that I asked, 42 is doing the tax preparation by hand, and the expected frequency is the one that we are calculating ourselves, doing the algebra behind it. 300 in the survey times 20%, which is 60. Computer software from previous page, 35%. Observed frequency, 112. And then the expected frequency, which is the multiplication of, remember, the product of the number of adults in the survey and the probability that an adult will use a particular tax preparation. That's why you do the multiplication here. Remember, from previous page, we had N times P. And then friend and family from previous page, the hypothesized one was 6%. From our survey, we have 29 people, so the expected frequency is 18. And finally, tax preparation service from previous page, the hypothesized one was 15%. The observed frequency is 56, and then the expected frequency, which is 45. So what's the use of these tables? What's the use of observed frequency and expected frequency? The chi-square goodness of fit test is following guidelines here. To perform the chi-square goodness of fit test, these conditions must met. First, the observed frequency must be obtained using a random sample. 2, each expected frequency must be greater than or equal to 5. If these conditions are met, then the sampling distribution for the test is approximated by chi-square distribution with k minus 1 degrees of freedom. K is the number of categories, an important piece of information for us. Then the test statistic is chi-square equals to the summation of observed values minus expected values to the second power divided by expected value. So to find the test statistic chi-squared, we need to do a little bit of algebra. After calculating the observed values, doing the subtraction for expected value, raising them to the second power divided by the expected value, you add them all together. This is going to be your test statistic. Make sure to specify your null and alternative hypothesis, specify the claim. Specify the level of significance. If it's not given, it is 5%. So by default, if the level of significance is not given to you, use 5%. Identify the degrees of freedom. Remember, K was the number of categories. Determine the critical value. Determine the rejection region. Find the test statistic, which is your chi-squared. Check to see if chi-squared is inside the rejection region or not. If it is inside the rejection region, you're going to reject the null hypothesis. Otherwise, you're going to say that, hey, we failed to reject the null hypothesis. You could also use alpha and compare it with the p-value as well. So we have different options when it comes to hypothesis testing. In this case, we are using the rejection region. So let's go back to our example. A retail trade association claims that the tax preparation methods of adults are distributed as shown in the table. So I move this to the right-hand side so I have enough space. A tax preparation company randomly select 300 adults and ask them how they prepare their taxes. The results are shown in the table. At alpha equals to 1% level of significance, test the association claim. Okay, beautiful. These are the things that we calculated ourselves. Remember that? We did some calculations in previous page. We had the hypothesized information in the first table. Then we ran a survey. We collected this information. Then we did a little bit of algebra. So let's follow the guidelines. The observed and expected frequencies are shown in the table. The expected frequencies were calculated in previous example because the observed frequencies are obtained using a random sample, and each expected frequency is at least 5. You can use the chi-squared goodness of fit test to test the proposed distribution here. Okay. We did the calculation, tax preparation method. We saw that the observed frequency is 61, expected frequency. We did the multiplication. And then by hand, computer software, friend and family, tax preparation services. So whatever we calculated from previous page, we are writing them down all here. Why? Because we need these to calculate the test statistic. Null hypothesis says the expected distribution of tax preparation methods is 24%. By accountant is 20% by hand, is 35% by computer software, is 6% by friend and family, and it is 15% by tax preparation service, which we know it is our claim. Now, it's opposite. It's not. The distribution of tax preparation methods is not the same as the claim. Since we have 5 categories, the chi-square distribution has degrees of freedom equals to 4. 5 categories. This is the first category, accountant. The second category, by hand. The third category, computer software. The fourth category, friend and family. The fifth category, tax preparation service. Degrees of freedom is 4. With degrees of freedom 4 and alpha level of significance 1%, the critical value for chi-squared is 13.277. The rejection region is where chi-squared is more than 13.277. With the observed and expected frequency, we can form and calculate the test statistic. Remember the formula for the test statistic. Chi-squared is equal to summation of observed value minus expected value to the second power divided by expected value, and you do the addition for all of them. It is equal to 61, which is your observed value, minus 72, which is the expected value. Raise it to the second power and divide it by the expected value. But this is for the first category. Now we have to move on to the second category by hand. 42 minus 60 divided by 60. Remember, you need to raise it to the second power as well. Plus, the next category, computer software. Observed value is 112 minus 105, which is expected value. The second power divided by the expected value, which is 105. Plus the rest of the categories, friend and family, tax preparation service, 29 minus 18 to the second divided by 18. And finally, 56 minus 45 to the second divided by 45. If you do the algebra, it is approximately 16.958. But remember that our critical value was 13.277. Since our critical value is right here and your test statistic is more than the critical value, it is inside the rejection region. It means that we reject the null hypothesis or we reject the claim, because null hypothesis and claim are the same thing. There is enough evidence at 1% level of significance to reject the claim that the distribution of tax preparation methods and the association's expected distribution are the same. So for the chi-squared, you can use chi-squared table, which is down here. So here you have the chi-squared distribution table. If you Google this, you get the table for chi-squared. So here you have chi-squared of 1%. Take a look. It's 1%. So we are looking at the column for chi-squared for 1. But the degrees of freedom is equal to 4. So since degrees of freedom is equal to 4, you're looking at this row. And the intersection of this row and this column, 1% is 13.277, which is exactly the same as what we did in our calculations. So here you have 13.277, which is our critical value.